Okay, yeah, now I'm recording the video.
Okay.
Thank you for accepting it.
No, of course, of course.
Uh-huh.
My name is Sean. I'm a junior in undergrad architecture at Rhode Island School of Design.
Mhm,
And our school is not as passionate about, well, computational architecture as well,
mhm.
other schools, etc., because it is a fine arts space school,
Yep, yep.
valuing traditional craftsmanship as well as social concerns.
Mhm, mhm.
So I had to sort of kind of find a path for me within or outside of school to um, learn more about algorithmic architecture as well as design and
Mhm.
etc. And I came across your videos
Oh,
on tutorial on Grasshopper. It was very accessible, especially for Korean or English speaking people.
mhm.
And yeah, and I finally added you on LinkedIn and I asked you if
Yeah.
I could have a coffee chat.
Yeah, I mean, I'm very open to communicate with people like you, particularly students or professionals who are interested in learning computation design. So I think this is kind of my sort of vocation and job. So I'm happy to interact with people in different ways, like Zoom meeting or whatever. So yeah, I mean, because I'm also while I'm communicating with people, students, I'm learn a lot. Because sometimes I need to because think about it, I'm very highly specialized in profession in one my area, right? So meaning that I'm maybe my perspective will become narrow, too narrow, maybe in a sense. So I think in order to communicating, teaching or sharing the information, I think understanding the audience is really important. So yeah, I'm very happy to talk with you, and I'm excited. I mean, because that's why I'm respond to your message in LinkedIn quickly. Yeah, no problem, no pressure. Just like your friends, you can talk and can ask whatever you wanted to ask me.
Of
Mhm.
course, thank you. I mean, speaking of, you mentioned that you're afraid of, or you might be narrow in your realm, or etc.
Mhm.
I remember you mentioning in one of your videos that there are similar traits amongst all 3D softwares. I think
Mhm.
this was a AR, like the advent of AR VR architecture and people worrying about, like following the trend. But you mentioned that or not philosophically, but systematically, all 3D software coding languages have their own. If you understand one, you can
Yeah,
sort of access everything.
exactly.
So the question was, as much as these tools provide us these potentials, do tools shape us as well?
Mhm.
Um, in the end,
Mhm.
like I think that was pretty much like in your profession and experience, do you feel like sometimes the tools that you use, you don't shape them, but they shape you in a certain sense?
Yeah, it makes sense because my understanding of your question is that basically we are designer, right? Designer some way confined with the material and tool, right? So think about it, you have only concrete or some stones or plastic, but that material actually forces you to do some particular shape or particular way of cooking the material. So in that sense, I think that the most important thing I believe is that understanding tool is important. So what I mean by that is the ranging from possibility to limitation. As long as you understand what the tool stands for, then you can actually take advantage of the tool, or you can avoid of the tool. So I think the most important thing is that as a designer, your thought process, like a design process. So the importance of the computation design speak out on my channel is about basically translating human, the design process into the code. Or sometimes we need to use the current commercial software like Rhino, 3ds Max. And it has its own sort of, limitation and the possibility. So yes, to answer your question, the tool actually, shape my design process or my thought for sure, I think. Mhm.
Yeah, I think that was a That was actually quite helpful in understanding what tools can do. Actually, I was quite wondering because I'm pretty sure you predominantly use digital tools, etc. I was wondering if you ever go back to the physical and sort of work with those, or like do you just start from digital prototyping? And I guess like it depends on each job, but it was an interesting experience for me because when I came in, we start architecture in sophomore. First year is called EFS, which
Okay.
is when everyone has to do a foundation in fine arts work, etc. And we start in sophomore. I After I discharged from the army,
Mm.
I just they call it 군대 부스터, you know what I mean?
Okay. Okay.
I just kept on digging grasshopper, and then
Uh,
when I came back to RISD, my
you did
professors kind of,
you
pardon?
did military service in Korea or in United States?
Oh, I did in Korea. I'm a Korean citizen.
I see.
Yeah.
Okay.
Um, and yeah, I just left straight after freshman year. My dad just signed it. Just sent
Yeah.
me off.
You're a good guy. Yeah.
But um,
Mhm.
and my professor sort of, I guess it's because it's my first year starting architecture, but my professor sort of tried to kind of push me away from Grasshopper or these algorithmic tools.
Mhm.
They were quite afraid that it's in terms of when with automation,
Mhm.
you lose the intuitive skills apparently, like lack of control.
Mhm.
Um, so it was quite difficult to be in an environment where everything else you want to learn is not really supported within RISD.
Mhm.
Um, and I was perhaps wondering how much control can you have in these sort of um, where everything we're doing is building a platform for better design or et cetera. Like in terms of architectural building, where's the fine line between control and automation in your experience?
Yeah, I mean, this is a very broad question, to be honest.
Yeah.
Uh, I'm thinking, where should I start? First of all, you started studying architectural design in university. So, paying back a lot of tuition and time. But I
Yes.
think most important thing is that to follow the pedagogy of the SV and sorry, rigidity, right? I'm sorry. So the one thing I can tell you in this way is because the school has their own philosophy and some strategy to educate their students. I think in that sense, in order to maximize your time and your effort, I think to follow that direction is the top priority, I think. Yeah. But at the same time, the perspective that your professor mentioned is I'm kind of agree and disagree because I feel like this is not some, how can I say, digital tool versus analog tool. It's not happen like this. It's like a tool. Some people prefer taking bus to go to other state, for example, or some people would like to take airplane or bicycle. It depends on the distance and depends on your goal. So the reason I'm saying is because, once you fully understand the digital tool, but the older guy has a lack of experience and lack of time to
Mhm.
expose to that thing, so that they're trying to analyze, they're trying to, understand on the basis of what they have, like as a
Mhm.
bias. So in that sense, I'm kind of experiencing two different worlds at the same time. I mean, throughout my design history. So I think if I were you, I definitely follow the direction of the school, but at the same time, you need to keep your interest and your vision because school's responsibility is to make the student like before graduate, you guys need to be well around. So that, oh yeah, legally architectural students, they are good because they are minimum qualification. Yeah, things like that. This is all about the school's responsibility. But after that, meaning that the school doesn't care about your future. Yeah. You need to find your own way.
Definitely.
But at the same time, even if the very traditional and conventional and conservative school has some professor who is very into new technology, so I think it's very mixed feeling. I feel like so. Also, you mentioned like the intuitive human thought process and automation. This is also a very controversial topic, I guess, because on my eyes, it's basically identical. Yeah. In order to make them automate something, we need to, think about how we make the process as an automatic process. Yeah. In this case, if you have better design experience and better sort of sub process, then you are able to make the automatic process become more meaningful. Yeah. I mean, as a designer, again, as a designer, we basically utilize the tool in a sense in order to, utilize the tools successfully. If you understand, again, like a limitation and potential of the tool, then you can just mix or whatever. You can actually exclude some unnecessary tool. Many people want to use it, So make your question shorter. I think I follow the rigidity, the pedagogy. At the same time, just keep your interest and then see how the world goes, data become more and more important, and also the tool evolve a lot quicker. And why not? We are designer. We live in 21st century. Come on, we are not like old fashioned. I mean, there's an old fashioned tool. I like to use old fashioned, but why not? Why not we don't use the current cutting edge tool like state of art model or software, things like that. So as you use smart designer, I think don't follow the tool, just take advantage of the tool. Yeah, it depends on what you want to achieve, what you want to design as a designer. I think this is the more important bottom line, I believe. Yeah. Is it right question? Right.
Yeah, I think so. That's so important that your intention precedes the tools. Um,
Additionally, once you have enough experience to design in a conventional way, which is actually all about the way of thinking, I think, then you have a better position to understand the computation design or whatever cutting edge digital technology. But without this kind of experience, maybe you have just follow some tutorial of the Grasshopper, for example. I think that situation, the most of the professors don't want to put their students, I think. Yeah. And also I met a lot of students, they struggle to learn computation design, but I guess it's not about the computation design. It's more about the lack of your design experience. Yeah, that one very openly happens. So I think when considering your experience, you are a sophomore, right? So I think yeah, just right now don't be stressed out. Yeah,
yeah.
just follow whatever studio, whatever professor you pick on that particular studio during your the journey in the school, and then just follow, try to learn from out of the professor and students in the studio. Then at the same time you can just keep learning coding and Grasshopper. Right now you don't need to worry about making something special out of this kind of technology. Just enjoy it. Yeah, I think. And then once you reach a certain amount of the experience, then actually you automatically, yeah, naturally you can mix two different thought process and implementation for your design. Yeah.
When did that sort of happen for you?
Yeah, this is a good question. So actually my history was a little bit weird. Hmm. So I started it from high school for my architectural design journey.
Oh
And
wow.
then I went to my university, and then most of the people use the AutoCAD for 2D, and some of the people use the hand drawing things like that. But I don't want like compete with them because I'm not interested in waste of my energy. I just want to push my boundary. So I wanted to learn something not many people can do, like 3D at that time.
Mhm.
So I utilize a lot of 3D graphics and 3D math experimentation in my studio. And unfortunately, my professor was very, very traditional guy. Actually asked me, Andy, did you come from computer science? No, 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 no. I'm an architectural designer, and my background is starting from my high school. Then can you draw by a traditional way by hand drawing? Yes. Then most of my friends actually using AutoCAD, not me. I just need to draw hand drawing for my section and elevation because of my professor. Anyway, I just followed that direction, but I kept my passion. And then things change. Many people, you know, did some 3D AutoCAD and rendering and things like that. And then I realized that, okay, 3D is not no longer, become specialist, I think. Then I'm trying to learn like 3D animation and VR. At the time, the VR was also like first or second wave. So I try to utilize this kind of visualization tool for my design process, because design process is all about like iteration, right? Design something, experiencing, and the modification and experience, this kind of the iteration process. So I, rather than, draw something on the paper, I just actually literally build in the three-dimensional space. And for sure, it has a the pros and cons. But I try to, explore the possibility. And then my interest is shifted from the 3D model animation and simulation to the parametric design and coding and things like that. So I have no computer science background, but I'm very competent, um, you know, migrating my design process into code. This is because I already experienced a lot of 3D tool like Rhino, 3ds Max, and Maya. And then also I have a experience um, how to, design from nothing, because you have a site, for example, like I know how can I, um, control the site all the way to the building. There's a lot of strategy, as a student, we learn how to, control the process, right? So it's nothing special. And then I learned code, and then yeah, I spent a lot of time to understand like basics of the computer science. It's not about like easy, but just try to learn what is the variable, for loop and basic syntax. Yeah. So I mean, this is all about understanding language. So what I'm trying to say is that once you graduate, I'm for sure you have all the language for the architectural design. You cannot articulate, but at least you can sense, right, how you develop your own design. And then somebody like try to ask you some question, or you can actually answer all types of questions because you did your design, right? Something like that. So what I'm trying to say is that once I fully understand the computer science thought process, like computation thinking, and then um, I'm trying to combine my traditional design thought on the basis of the computer science philosophy. So that was pretty fun part. And then yeah, I'm keep pushing my boundary. And then I'm not going to, I didn't go to follow the trend. Yeah.
Mhm.
Also, I'm not interested in like many students like it, because I feel like it become pervasive, and it become, it's not easy to get the competitive edge, if you follow the math, the people crowd. So my strategy is to really, really focusing on to, you know, um, create my concrete uniqueness. I think that one is kind of my survival kit. So just a little back to what you did. Yeah, just keep thinking. What's your strengths? If you have the weakness, yeah, just forget about it. But just focusing on the strengths and then don't lose your past experience. You need to keep your past experience and then keep like develop and make your own world. You make your own castle. Nobody can attack. Nobody can destroy. So I think you are very beginning of the architectural journey, I think. So within this kind of mental strategy, you will have better position as time goes by for sure, I think. Yeah.
Thank you for those words.
Mhm.
Actually speaking, that's very interesting that you said that you don't have computation, I mean, comp sci background.
Mhm.
Actually, I remember reading literature called algorithmic architecture,
Mhm.
and there was like a case scenario where an architect and a software engineer, the team of architects and team of software engineers were given the same problem
Mhm.
and to solve. And the process was that architects focused more on iterative results as
Mhm.
well when software engineers were looking for the process of solving the problem. But
Mhm.
now you kind of found a way to concise
Mhm.
this field together.
Mhm.
Um, and I sometimes realize that when you build a platform, what who do you think when you build a platform for like these tools, like who do you think of the audience? Like um the platform for like Grasshopper or Unity, all these tools that you build, who are the audience? I think I'm kind of phrasing it wrong. Um I guess that I guess what I'm trying to say is the process sometimes underappreciated
Mhm.
compared to like these concrete results
Mhm.
that I mean, out of thousands of building prototypes that we can build with algorithms,
Mhm.
it's only going to be one that's going to be built. So
Okay.
where does these thousands of other, you know, where do they go?
Yeah, I mean, it depends on how you wanted to analyze your design. I guess let me make an example. One of my friends asked me, NJ, you are very into computation design. Could you tell me which building is done by that way? Then I'm trying to understand the question behind the scene. Um, so I actually asked another question to my friends. Could you tell me which building is done by Revit, for example? Yeah. It's kind of nonsense to me. The reason I'm saying is because as a sort of position or like a problem, um, let's say architect basically generate document, right? And then builder or construct engineer, they actually then, analyze the construction problem or you know the constructor or general builder, they basically build actual building out of the document, right? So I mean, what I'm trying to say is that basically computational designer, as an output, they build process and make it as an algorithm. Yeah. So it depends on the how you see the problem. And also we can think about like architectural design between I mean starting from A to zero, right? Sorry, starting from because some message is coming. Sorry. So starting from A to Z, right? So we basically have a site, an idea, right? And then we can keep build and then we can get some iterative process. Sometimes we can just come back to the ideal phase to redesign your concept. but at the end of the day, the output gonna be as a building or what kind of a physical, tangible, outcome here. But during that process, we can actually narrow down or break down the process, and then you can sense like very particular problem, right? What is the, for example, like input or what was the output? You can actually narrow down and break down the problem like this way. Then maybe in that sense, computational approach, like a CS mentality can have much more benefit compared to the architectural thought process. It totally depends on how you, what kind of tool. I mean, the thought processes become as a tool, right? So what kind of a tool or what kind of like an output you expect. So it's
Mm,
pretty like a mixed feeling. And I mean, the reason you asked is because you are still thinking like, there are different tool between traditional way and
mm,
like a binary condition, like a black and white thought.
yeah,
But
yeah.
I'm keep saying it's not about the black and white or not about the binary condition. It's more
Mm,
about like the understanding problem correctly and then utilize the tool efficiently and correct way. I think that one is the answer broadly, I think.
mm,
Mhm. So yeah, it totally depends on the problem. And for example, like let's think about like urban design, right? For the urban design, basically they are not going to be build actual urban because it takes time, right? Basically, they need to show some vision or some, sort of, I don't know, maybe some infrastructure or some like very high level policy or whatever in order to resolve their problem, right? For example, in that context, like gentrifications happen, for example, and then it become like a very crowded, for example. This is kind of a question, right? So how can we resolve that question? Maybe some people like utilize some cultural solution, or you can physically install or some redesign just some infrastructure. It totally depends on the people. And even if you have this kind of tangible goal, the way of doing is actually can be different. So that's why I'm saying like this is all about like the design process. Just don't think about like computation and other tool. Just as a human being, you know, we have a language, right, as a tool. So how can I articulate the problem? Yeah, I'm not saying the problem is going to be resolved from A to Z.
mm,
Just like as a big journey, you can just narrow down. Sometimes we can, without any computer, we just keep thinking. Sometimes we can just, without thinking, just keep clicking computer software, things like that. So, yeah, I mean, I'm kind of guy. I'm not a like, technology become change our world. I'm not believe. I mean, again, this is the kind of tool. That's it. Yeah. Mm. This is my thought, I think. I may be wrong.
mm. Oh no, no, actually, definitely. I think you pointed out something that I had internally, which is you're right. I think I did segment
Mm,
these tools as different breed when actually I kind of
mhm,
lost power when I sort of doing that. Like I think what you saying it actually empowers the designer if you say that it's the designer that chooses the tool for
mhm.
appropriate situation, not the
Exactly.
other way around. And I think that was something that I really it's obvious if you think about it, but I kind of forgot. And I
Mhm.
think it's something while you're talking, actually, I was
But I guess
having a little epiphany.
yeah, but I think on your stage, you don't need to like think too much about what I'm saying.
Mhm.
So I recommend you to just explore everything, just enjoy it. Yeah, just play with the grasshopper, play with code, download, whatever, algorithm. Just tried it. And you can actually bring to the output with your professor. Then you
Mhm.
probably get a lot of criticism. Yeah, that's accepted. Yeah, just keep
Yeah.
learning. So while doing these kind of activity, I think you kind of understand like what is the weakness and strengths, and then you can basically
Mm,
can have your own boundary, yeah,
mm,
based on your experience and feedback from other professions. Yeah, I mean, I'm very positive to using the communication design, so
mm,
my feedback is gonna be really positive. Makes sense, right?
mm, mm,
There should be a lot of people who opposite me, yeah, for sure. So I think gathering this kind of information and data, and maybe after 10 years, 20 years, the bias should be changed for sure. In that context, maybe students in the future, they have a better, environment and better stage to learn because many professions, they already used to use this kind of cutting edge technology. And for sure, I mean, my dream is that I need to learn code because I'm designer.
mm,
I really want to make sense that sentence in the future. Yeah, because it's gonna be our future for sure. Right now, think about it. You're a designer, so that's why you can use Photoshop or AutoCAD. It makes a lot of
mm,
sense. But think about it, like 20 years ago, when I started my architecture journey,
definitely.
if you use AutoCAD, then you are not designer. You are not
True.
designer. Yeah. People think about you, you are not you're technician. Yeah. So this is the bias on that um period. But right now it's kind of a mixed period right now. But after 10 year, 20 year, well, you become like more profession, you will be very active. So just your targeting is not right now. Your targeting is like after 10 years or 20 years. Just take a look. Don't follow the ball, to predict the direction of the ball. And then you can actually predict the trajectory of the ball. Then you can just focus like alone rather than following the ball itself. It's like a, um, you know, yeah.
Actually, I remember you mentioning that we're not actually competing with our peers or the
Yeah,
seniors, but the future, like
exactly.
someone 10 years or 15 years younger than me when I'm deep in the field.
Yeah.
Um, that's a daunting thought. That's a scary reality that seems to be more true, like truer each day. Um,
But
but
go
what,
ahead.
um, and actually, I guess like I'm not sort of, I think when I saw that video, I remember what you said was just kind of see them as opportunity, not as elimination of our career path or whatever. I mean, with the advent of Mid-Journey, all these AI tools that are
Mm,
happening,
mm,
even my like peer friends are sort of scared or threatened. I can kind of sense
mm,
that, when someone pushes a boundary, the people who are like kind of used to a system are quite scared. And with all these tools that are happening, like what is the last layer of onion for us? Like, um, it's just something that I was thinking every day because all these, chat GPT, all these things are happening, and I'm just like, wow, I'm a student, and I'm just so like there's so much unpredictability in terms of the future.
mm.
What's really it's like sometimes it makes you wonder why, like, oh, why we're learning these tools or etc. When there's a machine that's like thousand times better in terms of not thousand times, but
Mm, mm, yeah.
mimicking these images.
Mm.
Um, do you think about those things like um and the future direction of design?
Yeah.
Um,
Yeah. I kind of understand what you try to say.
yeah,
For sure, no one actually predict. No one predict our future for sure.
yeah,
But the important thing is that I mean the world is crazily faster and crazily like unpredictable. And yeah, as a profession, I have a lot of sort of I'm kind of exhausted to follow all these kind of to be honest. But one thing I can tell you is that the foundation is actually never changed. Yeah, ever, ever. So um, there are different types of topic in your question. The first of all, um, if you learn AI, and also you can take a look at the result of the AI, and then also you can compare with this kind of the things with some professionals, like for example, like Jeffrey Hilton. He's like one of the father of the AI. Also, you can listen his lecture, or you can also take a look at some feedback from the businessmen like Mark Zuckerberg or um, the Elon Musk. I mean, based on their position, they have a little bit different types of the understanding and fear and the imagination, I think. But most of the AI we utilize right now is actually heavily relying on the data. Yeah, heavily relying on data. So I also had a workshop at GSD for the AI things, and also I participated in some AI related something, the studio, whatever things. But I think most important thing is that data, to be honest. The model or network is there. Yeah. What kind of the data we wanted to train the model for what kind of question, like what kind of a problem? I think the question become like again understanding problem, like design problem, whatever problem, and then collect and process the data that describe your problem. And then there's a lot of nice and very fine-tuned model and AI network, so then you can just take advantage. So what I'm trying to say is that still designer need to understand the problem correctly. I'm not talking about the GPT or again or other very, very generic AI. I'm talking about the AI as a tool for designer. So in that context, again, it's a little bit different approach, but the foundation is the same. Understanding problem and then narrow down problem, meaning that you probably understand what kind of data has a more insight, with less knowledge, for example. It's all about like the procedure and designing things. So I think right now, current approach, I think it's nothing seriously sort of um, how can I say? Um, I mean it it is just glow itself. So it's just different compared to the human design capability, I think. Just as a design tool, we can actually, you know what, if you learn AI a little bit, then you can understand what I'm trying to say. Like it's more about like a programming, different types of programming. Yeah. So I'm just wonder why people like some program done by conventional way, and there is another program by AI approach. Then people put more emphasis, or people can see the AI is way, way better than the traditional software things. So think about it, like, come on, Elon Musk like shoot the rocket and then the rocket is actually return on the land, right? It's just crazy, right? So this is done by like I don't know, maybe they can use some portion of the machine learning AI model, things like that for sure. But most of the programming done by like plus minus multiply divide, like very simple algorithm. So I actually write this context on my book. So think about it, how creative, the software engineer, based on very primitive computation, they actually shoot the rocket and then come back the rocket pass on the ground. It's not easy tasks. So I think on the business wise, the CEO, many people like Elon Musk and Mark Zuckerberg, they actually kind of take advantage of the imagination of the AI. But partially, in a sense, it's absolutely correct. But the way of the using is, I think, is very similar to what we have been done. Yeah. Think about the GPT chat. Yeah. So actually, the other day I talked with my friends about the GPT chat. Amazing. Yeah, it's amazing. Absolutely amazing. Yeah, but it's not difference between the GPT chat and a person who good at Googling. Yeah. They're basic, but in terms of the speed, GPT chat 3 is a way better, right? But what I'm trying to say is that GPT chat is basically generate the sort of the answer out of the data we inject, like wiki or some paper or whatever things. Yeah. But think about it. Um, without this kind of data, maybe we can create the GPT chat like model AI later. Then maybe it become actually more problem. Just like Elon Musk said, like the AI become much more dangerous compared to the nuclear bomb. So what I'm saying is that like whatever GPT chat 3 said, we can actually predict because we feed the data to them. So this is kind of the predictable. Yeah. Same as the design. Yeah. So, but just think about it, like without any other human beings inject, because human beings generate the data. And then based on this data, actually we can train the model. So it's just a little bit different representation, like implementation. But I think maybe uh, next upcoming decade, we can have another way of training the machine. Then we can have I mean, this is very tricky part. So I think it takes much more time to convey all my sort of worry and opinion correctly to you. It's kind of nonsense within very short time because also I'm very into that topic as well. Also, I can say something that I'm saying, which is opposite way in the opposite way, I can say. But yeah, just come back to the design practice that. So I guess just think about this as a tool. Yeah. So you need to articulate. As long as you can clarify your problem and then set up your own process. And then during the inside of the process, you can actually use the AI or whatever tool. And the last one, as an example, I heard that one of my students in the workshop, he said like, oh, in the studio, somebody bring some image to the professor in the studio. And then the professor asked him, what is this? And then he said like, oh, based on this keyword, I generate this image. Oh, AI generate this image? He said, yes. Then okay, so what do you want? I mean, what's your purpose? He's just saying like, because this is generated by AI. So it's gonna be good. But I don't think so. Why? Why we are impressed by that image? This is my question. I mean, if you articulate the problem, if you say like the advantage of the implementation of AI in your design process, if it is makes sense, then it become useful. It become acceptable to other people. But however, if you keep saying like, I don't know, this is just AI is generated and this is the done by some fancy you know fancy AI implementation, then I think it is meaningless.
It's
Yeah,
just AI bibimbap. That's
yeah. So again, in that context, the most important thing is that the foundation and thought process. That's why I'm keep saying technology could be getting evolved. So then the correct position of the designers, just take a look and then think about what is our opportunity, what is the pitfall, what is the sort of the unknown potential. I think that stance is important, and at the same time, you don't need to worry about like the development of crazy AI things for the design, I think. Yeah. Yeah, I mean, this is a very crazy topic.
Yeah.
I hope my opinion helps you. Yeah.
No, of course. I mean, of
Mm,
course, despite all these things, it
mm,
was just never really a fear. It just was just something on the back of my head. That was
yep,
pretty
yep.
much it. But yeah.
Mhm.
Um yeah, I mean, I would I mean, I don't know. I think you also have precious time and um I really want to talk to you more, but I also have to leave soon. But
Mhm.
um I guess I did me being a junior, I guess I did hit a roadblock in terms of the tutorials or all
Mm,
these things that
mm.
I've scoured, all the PDF collections or whatever. Um, but I guess from my perspective, where could hmm, do you have any recommendations for certain literature or certain um I guess your videos alone are actually really useful, but any literature that you studied in the past or whatever that I could perhaps like look into and sort of kind of study on my own.
Okay.
Um,
Yeah, I mean, it fully depends on what you are interested in right now, I think. So, it's really hard to say because I haven't
oh,
known about your interest
oh,
right now.
yeah,
But one thing I can tell you is that as an architectural student, important thing is that dealing with the studio, right? Yeah,
yeah,
from the understanding site to
yeah,
build and creating some section and elevation and things like that. So let's think about this process like A to Z, right? So A to Z, probably some phase in design process, you should rely on your intuition rather than computer software or something like that. But some stage you need to take a look at data, right? In order to understand, in order to analyze your design process, for example. So if you phase, some particular design phase with data or some automation. I think the automation is always a good place to apply computation design for the
yeah,
beginner. Yeah. So just focusing on your studio and then just open your eyes big and then just think about like what kind of opportunity is there.
mm,
Then, if you found something that are you interested in, like using Grasshopper automation or some data visualization or things like that, don't use other crazy software. Just stick to the Grasshopper because Grasshopper is like very designer friendly interface, and also that is actually running on top of Rhino, which has all types of graphics and geometry computation. So in that sense, just you can just download some examples from a website or just follow some not random tutorials. Follow some particular tutorial that potentially stick to your design studio. Then just you can just take advantage of it. Don't necessarily mention, oh, I use this kind of algorithm, to the
yeah,
professor. Don't do that. Yeah,
yeah,
this is like a maybe it actually create another noise. Yeah, anyway, so yeah, I think that kind of approach is the one of the easy way that I usually recommend for the students. Yeah.
mm.
Mhm. And also,
Uh,
if you're interested in learning language, then I recommend you using Python. Yeah. Also, Grasshopper has a place to execute Python. Mm-hmm.
yeah, it was Iron Python. So it didn't have the APIs that it usually has on Python 3. Um,
Oh, actually, you don't need to worry about. You don't need to worry about. So basically, the procedure and way of creating algorithm is identical. Yeah, and also you mentioned API. You don't need to worry about the API of the other software. You must understand API of the Rhino. Yeah.
Mhm.
So
Scripting.
at the same time, I guess you are familiar with using Rhino, right?
Yeah.
meaning that you have a really, really good position to understand the Rhino API, because Rhino Python API is nothing special. It's just kind of a wrapper of the icon on Rhino. Mhm. So I think from my experience, this is the easy and fun way to learn sort of computation design for the beginner or architecture students. Yeah.
Um, is it okay if I well, I was
Mhm.
wondering if I could show you some of the scripts, but
Yeah, yeah. You can
I guess that could be another day. Because
yeah, 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 for sure.
yeah, but uh, actually, that's I did have some questions because
Mhm.
this was my. I'm sorry, I'm usually not this nervous, but
No problem. Take your time, please. Yeah. I like your passion. Yeah.
thank you.
Uh,
Um, is it okay if I could share the
yeah,
screen?
yeah,
Thank
you can.
This was actually,
Mhm.
I think, in terms of like the purpose that you mentioned. I remember when I was doing a laser cutter, I was wondering,
Mhm.
is there any tool that efficiently lays out all my cuts onto a panel? And I was trying to develop them, but I realized that there's already tools like that on
Mhm.
Food for Rhino.
Mhm.
But it was actually, but because I was
Are you
so
sharing your
eager.
screen?
Pardon?
Are you sharing your screen?
Oh,
Yeah. Here we go. Okay. I can see your screen. Yeah. Yeah. Yeah.
um, oh, this is not it. Oh,
Wow. Wow.
I
Wow.
was, I guess my question is that I'm inefficient. I was like, um, so
Okay.
the assignment was just 8 by 11 inches. We're
Mhm.
building a footprint, and I wanted to sort of, um, unfortunately, I realized that trying to automate
Yeah.
fabrication itself took a lot more work than the design. And um, so, like for example,
Mhm.
if oh, that's a lot. For example, if I wanted to
Mhm.
access
Mhm.
just these surfaces, I was wondering how do I just select the large cuts that I want to have and sort of lay them out onto a laser cutter as
Mhm.
in a most like material friendly way
Got it.
possible. But these were all just I realized that hold on, I'm not automating anything. I'm just kind of doing Rhino on a
Yeah.
grasshopper interface.
Got it. Yeah.
And that's the roadblock that I felt when I realized that um
Okay.
it's kind of going against the very nature of what I was trying to learn. So
You know what? Actually, if you decompose any algorithm out there, that algorithms actually is nothing special. Yeah, just like you did. But what we can see is just the input and result. That's it. That's why we cannot see the complexity or some crazy computation behind the algorithm. I think that you are on the right track. Yeah. And also, while you creating this kind of complex grasshopper component, you kind of exposed to that kind of the procedural thought process. Yeah, I think. So one thing I can tell you by looking at this crazy grasshopper thing, you can because think about it, like individual component has their particular job, right? So maybe you can merge two or three into one component by Python.
Mm,
Also, basically, you can modularize the Python, and then if you modularize the Python, the meaning that you can also like generalize the component so that you can use here and there or other project and things like that. It's like a creating your own sort of library, which is kind of your worker in your company. Yeah, for example. So again, not doing trying to resolve crazy complex problem, just starting from the simple problem and like a simple extrusion, for example, like in that situation, I want to extrude that amount of the thickness, for example. In that situation, in that condition, I don't want. Yeah, so I want to apply another sort of a module, for example. So, I mean, if you have a time, just take a look at what is the computation design thinking. Most important is computation design. I'm sorry,
mm.
computation thinking. So, principle of computation thinking is basically understand problems correctly, and then decompose the problem, and then you can also abstract the problem. So meaning that you can lead over all the noise and then just remain the essence of the tasks. And then you can actually break down, modularize, and then you can now make some procedure based on the condition. So this is actually what you did. Yeah, I can articulate if you zoom out this algorithm, everything. So this is all about like computation thinking implementation, basically. So I mean, I used to create that kind of algorithm before. So most of them is basically translating the manual operation into the code. But and also one thing you asked me is that which is very crazy problem. Like for example, how we position the how can I say the component on the sheet in order to reduce the sort of the wastable material, right? That one is for sure is crazy complex problem. If you resolve it, then you're gonna make a lot of impact for the. I mean, there should be some algorithm, but there's also a way to resolve the algorithm if you are searching. Like think about like a Tetris, we have a given
Mm.
area, we need to put the whatever cutting object onto the sheet, right?
Yeah, I was actually thinking about using kangaroo physics to sort of merge it onto a surface so that they could just fall and
Mm.
kind of, I guess it won't,
It's more complex to be honest. We don't,
yeah,
don't
it's
not,
definitely
not about the position, but about the rotation.
rotation. Yes,
Everything
yes.
is like interconnected. So maybe in this case, you can do some novel strategy to put the object on the sheet, and then you can make a lot of iteration, like thousands of iteration, and then you can get the like a best the result out of it. Like this is one of the optimization things. Anyway, yeah, there are many things in terms of the technical aspect of it. Um, yeah, but I think you are good. You are on the good way. Yeah, just keep pushing yourself, and then I mean, important things the question and curiosity. Yeah, just don't lose them. Yeah, and then these kind of activities should be connected to your design. Anyway. Don't lose that kind of connectivity, you know.
Mhm, mhm.
Uh,
Thank you.
yeah, no, no
Yeah,
problem.
thank you so much for your time.
Mm.
I hope to, well, because my dream grad school is to go to Media Lab
Oh,
or
I see.
GSD as well, and I hope I could see you someday in Boston area.
Yeah, yeah, I mean, if you have any question, not only for the computation design, but also like, you know, your future, like master program or your
Of
profession,
course, of course.
we can share our knowledge and thought. Yeah,
Yeah, of course. I just really wanted to, like you said, push my own boundary in terms of design practice and
exactly.
yeah, be my own designer. Yeah, thank you. Thank you so much.
Yeah, yeah, no problem. And just let me know if you wanted to talk and have
Of
any
course, of course.
uh,
I'm just really happy that you took this call and
no
uh,
problem.
okay. Thank
And
you.
also, I recorded. I'm gonna upload on my YouTube, so then you
Oh,
can
of course.
just watch this video over and over.
Yeah.
The
Yeah.
discussion.
Yeah.
It's the beauty of the record, you know.
Okay. Thank you.
Okay, thank you so much.
Thank you, Namju. Thank
Okay,
you.
bye.
Bye-bye.